Today we'll be hearing from Dr. Malgwi, a researcher from Cometa in Italy, and who did his PhD at University of Padova, studying animal physiology. He'll be presenting to us the implications of changing age and weight at slaughter of heavy pigs on carcass and green ham quality traits. So, Isaac, the floor is yours.
Thank you very much for the introduction, and also thanks to PIGWEB for the opportunity to share insights on my first paper during my PhD. I would like to start with my favorite quote from 𝗵𝗵𝗃𝗃. Okay. 𝗵𝗵𝗃𝗃, we all know him, he's a mentor in the PIGWEB. I love this thought-provoking sentence. It's a chicken, just a pig with feathers. And I try to play with his phrase, and I say it's a heavy pig, just a heavy chicken without feathers. When we talk about green hams, we are basically talking about the hind limbs of pigs, which are harvested after slaughter and prepared in a certain way to produce a special product called dry cured ham. And Italy and Spain are major producers. Germany, France as well are key players. And the factors that regulate or control the quality of the green ham includes the age and the weight at slaughter, the slaughter and pre-slaughter handling conditions, the genotype of the pigs, the sex effects, and also the feeding management and diet as well. So in the case of Italy, the minimum slaughter age for the pigs based on the law is required to be 9 months. And the slaughter weight has to be maintained at 160 kilogram, plus or minus 10. For this reason, farmers are compelled or obliged to keep the average daily gain at 0.6 to 0.7 kilogram per day. And they practice restricted feeding based on a medium protein diet. However, there are ongoing guidelines that are now being put into law, those related to the quality based on consumer demands and those that has to do with sustainability and environmental impact of raising such heavy pigs. In addition, there is an increase in lean pig genotypes that fail to meet the minimum industry quality standards for green ham now. So this is a very, very serious thing because the losses and many other factors, which I will talk about subsequently, are not desired by the dry cured ham industry. Also, there is a decrease in the quality standards, which has to do with the ham adiposity, the major factor driving the quality of the green ham. So when the dry curing conditions are standardized, and these conditions include the temperature, the relative humidity in the rooms, once these are already controlled, including the, let's say, hygiene status of the rooms, the natural qualities of the fresh green hams determines the quality of the dry cured ham at the end of the curing process. Here I put this picture for us to just see what it means, the end fate of the green ham at arrival at the dry curing ham industry. So usually they arrive in this condition, and this is considered the best condition of the green hams. Subsequently, on the picture on the right, you will see that they are salted and kept, which is the initial step of the dry curing process. So the green ham aptitude for seasoning and dry curing depends on some qualities which the ham should have. And this includes the size and the weight, the fat covering depth, the meat color and the fat color, as well as the intermuscular fat. During the drying process, the air temperature and velocity, relative humidity, and the salt content and pH are very, very critical because the pH is one of the most important properties. That is the pH of the fresh green ham, and is measured immediately after slaughter and 24 hours after boning. and it's related to the properties of the dry cured ham because it has a kind of direct effect on the enzymatic activities, while indirectly also influencing the water holding capacity, the muscle structure, the color, and so on and so forth. And here I put SF is the fat cover depth. Subcutaneous fat cover depth is also an important attribute of a green ham. And the colored picture here, you can see this white path. It's a very, very important technological trait because it controls the sensory quality of the dry cured ham at the end of the dry curing period. And not only that, it controls the water loss, and it also determines the aroma, which is developed as a result of lipolysis and subsequent fat oxidations. Naturally, for a meat, the intramuscular fat content is also very, very critical, which is marbling. And the size is measured from this particular app. I want you to just take note of the unique shape of this ham, because if a pig-like, for instance, does not reach this desired shape, normally the ham industry, dry cured ham industry, do not prefer it. So it's a negative. I will just show some few defects. I won't speak about all of them, but when the green hams are harvested, you can see so many different anatomical defects. Those that are related from improper handling, for example, traumatic hematoma in this picture. And you can also see scratches here. It can result from pigs stepping from each other, or while one pig is laying down, the other stepped on it. And in the case of traumatic, it's actually welfare-related problem. And you can see tissue separation. You can see internal bleeding, although the colors are black and white. In this color, the picture is very interesting that I wanted to show us muscle displacement, because it's one of the major problems with most green hams that are used for producing dry cured ham. You can see how the two muscles are separated here or sliding on each other. Another interesting problem with most green ham is the veining, the problem of veining. So this can be associated also with the production management and how the pigs were handled before slaughter, especially during the large and transport period. And for some time now, for instance, after leaving the academia, working in a slaughterhouse in 𝗂𝗵𝗴𝗵𝗁, where we kill about 17,000 pigs per week. There are a lot of issues that you can see we are working on to prevent so many welfare problems associated with pigs. And basically, I'm trying to say that here, where I work now, the standard is maintained, and it's a very, very good thing to say that they're observing the welfare. But so many other slaughterhouses, because of probably lack of welfare experts, they fail to observe this kind of conditions or handling conditions before such pigs are slaughtered. And the stunning method could also result in veining problems, burning condition, that is 24 hours after the carcass are chilled, and the pre-chilling time. This will be related to, usually when the pigs are slaughtered, they go through the evisceration steps and then the cold shocking step in order to regulate the effect of high pH and low pH, which could result in DFD or PSC, depending on the rate of, just to reduce the rate of the glycolysis in the muscle. Anyway, so the aim and objectives of my study was to compare the conventional feeding practices for heavy pigs to produce dry cured ham with 3 alternatives. So I thought that feeding pigs ad libitum with high protein diets could reduce the age at which they will reach the desired weight. And once they reach that weight, I could, sacrifice them, and we could see their effect of the treatment. And the second alternative was to feed the pigs ad libitum with high protein diet just to allow them eat as they want and grow without any restriction. And the third alternative was to see if I can reduce the rate at which they grow to reach the slaughter age. So we applied feed restriction and fed low protein diet, and this will increase the time needed for them to reach the conventional slaughter weight. And we evaluated the effect of these three treatments on the growth performance, feed efficiency, and the quality traits of the green ham. So the study was arranged in a split plot design with the treatment and sex within a pane. We had a breed of pigs from Goal and C21, and this is a breeding center in Italy. And we had 4 treatments, 2 pens for each treatment. And then we had 2 sexes, so 7 pigs per pen, with a total of 28 pigs per treatment. And the total number of pigs per cycle of the investigation were 112. So we had 3 batches, and this gives us 336 pigs. The experimental group was arranged in this way. I will just call our attention to how we set the target weight and the age at slaughter. All the pigs arrive at 95 kilogram of body weight, and their age at arrival were the same. So they were farrowed at the same time. So to set the target slaughter weight, the control group, we set it at 170 all through to the older age and the younger age. However, for the greater weight, we allow it to go until we can see the capacity for growth of this genotype, so greater than 170 days. For the 70 kilogram, excuse me. For the target age at slaughter, we target to slaughter the control group at 270 days, the older age, obviously, greater than 270 days, while the younger age less than 270 days, because we anticipate that perhaps they might reach that target slaughter weight earlier. While for the greater weight, we slaughter them at 270 days of age. And we fed restrictively, medium protein diet for the control group. For the older age, we fed low protein diet, while for the 2 younger age and greater weight groups, they receive ad libitum high protein diet. In the course of the experiment, we used an electronic feeder that supplied the diet according to the daily allocation for the pigs based on the groups. And it records the time and the time spent during each feeding event, and also the quantity of the feed that each pig consumed. At the same time, we measure the back fat as we weigh the pigs every 2 weeks using the ultrasound device, Ren-Colin back fat meter. So this is a summarized diagram just to show us what happens with the green hams after slaughter. The green hams are harvested and evaluated immediately before they are resized or reshaped. Let me use the word reshaped. And there are critical parameters that must be observed. For example, the weight of the ham needs to be at least 17 kilogram, and the temperature average of 33.2, while the pH should be 6.1. Subsequently, they are reshaped or resized and put in a cold room, and they stay there for 18 to 24 hours at 0 to 4 degrees. So the following morning, we return with another device, which is an ultrasound, portable ultrasound system, to measure the subcutaneous fat depth. So there are anatomical points where you may have to take into account when you take such measurement. And so we measured in close proximity to the semimembranosus muscle with a ruler, while in proximity to muscle quadriceps femoris, we use the portable ultrasound. And an expert also scored the hams based on fat cover thickness from -4, which means very thin, to 0 to 1 being optimal, while 4 being thick. The same for marbling, round shape, and the incidence of veining. Now, to achieve our goal, of course, if you want to manipulate the growth rate of animals, you target diet, which is the easiest, and you will see a very classical result. So we reduce the crude protein content, for example, in the low protein finishing diet, while in the early finishing phase, while in the other medium and high protein group, we supply accordingly. So for high protein groups, of course, they receive the highest amount of protein. And also we alter the lysine from 4.6 to 8.3, from the low protein diet to the high protein diet, respectively. And the same you can observe in the late finishing phase. We alter the amount of crude protein supply to the low, medium, and high protein groups, as well as the lysine. And the low protein group receive the least, 3.6, and the highest is the high protein diet, which receives the 6.9. So for statistics, our model considered treatment, sex, batch, and pain. So treatment was a fixed effect, while sex was considered fixed as well. Batch is considered random effect. And then we look at the interaction between the pen and also within batch as a random effect. Subsequently, we run a orthogonal contrast. We compared the control versus the three groups: the older age, which is restricted leaf-fed pigs; the younger age, which are pigs fed ad libitum; and the greater weight, which are also pigs fed ad libitum. And the growth performance results showed a very interesting finding. For example, the feed consumption for the older age was higher, but compared to the control, obviously, while the younger age had a much more lower, significantly lower feed consumption in grams per day compared to the control group. And the greater weight had the highest feed consumption because they are allowed to eat ad libitum without any form of restriction. And if you look at the average daily gain for the restricted group compared to the control group, they had lower, significantly lower average daily gain. This is expected because we starve them, let me say, nutrients. While the younger age and greater weight group had a significantly higher average daily gain compared to the control. And at slaughter, the initial, the back fat depth, which is one of the most important traits of the green ham, was significantly higher or much more better than those of the control groups, while the greatest or the highest back fat depth in millimeter was measured in the greater weight strategy. So to look at the relationship between the carcass yield and the lean meat percentage, we observe a trend that is the body weight increases. For example, you will see an increase in the carcass yield, while the reverse is observed for lean meat as the growth is declining or restricted, the lean meat percentage is going down. And this is very, very important for us to see, because while customers will desire a more leaner cured meat, this trait is not good, or does not put the dry cured ham industry in a good position economically because of the losses associated with lean hams. Regarding the weights of the ham, so I put here in the first 4 bars the trimmed hammed SH at slaughterhouse. We can see that the greater weight had the highest weight of hams, about 15 kilos, while the younger age had 13.7. For the control, compared to the control group, it isn't so much different in terms of weight. At the end of seasoning, there is no significant difference between the younger age strategy compared to the control, but comparing the older age strategy to the control, you can see a very nice contrast because they produce these hams that are lower in weight, and the losses in terms of water loss is higher, trimming loss will be higher naturally. At the end, after burning, so after curing, we still check the hams. Usually the weight should be around 7 kilogram to 10, and the least was recorded in the older age groups. These are industry-driven parameters that determines the economic profitability of the industry, and that's why we had to measure these ones. And regarding the important green ham traits, which I talked about earlier, and I'll show us the pictures. And I will take them one by one. And for subcutaneous fat depth, you can see that the younger age strategy and the greater weight strategy compared to the control had higher. And the same if you come to the visible marbling. Although the older age is better compared to the control, you can see that if you look at here, the key here, that is the visible marbling, the optimal should be 2 to 3. So the younger age and greater weight are slightly not within the desired, but in terms of veining, we can see that it's much more pronounced as well in the younger age and the greater weight compared to the control. The last part was to perform an economic analysis to look at the feeding cost of raising each pig based on the different categories of the pigs we had. And the feed price in euro per ton as fed was highest in the greater weight and the younger age group compared to all the other two groups, for instance. And if you look at it in euro per pig produced, the most economic seemed to be the younger age compared to the control, while the greater weight strategy seemed to be a bit expensive, much more expensive actually. And the euro per kilogram of body weight gain, it's also lower for the younger age strategy. And when we say younger age strategy, what do we mean? That these pigs attain the desired weight at slaughter earlier than all the other groups. And that means that they had shorter days on feed. But then in terms of the quality of their hams, they seem to be promising. So to conclude, I can say that the younger age strategy was associated with more losses and production costs with increased veining and fat covering. And it's desired to be better because the lower the trimming losses and the cost of production, the better. And the greater weight strategy, it's a bit less desired because it increased the veining effect and fat covering just like the younger age strategy. But in terms of trimming losses and costs, these are things to consider as well. For the older age strategy, for sure it is inefficient because it increased the roundness was decreased, marbling, veining, and the cost, they were all increased. Meanwhile, the green ham weights on arrival at the green ham factory are not within the optimal range. And the take-home message here is just for us to bring things to perspective. The days on feed here, I forgot to mention it earlier. Compared to the control, the younger age strategy had 81 days on feed to reach the optimal green ham weight. Comparing the older age to the control, the older age had 124, while the greater weight had 108, almost the same as the control. And to calculate the difference in days to reach the desired weight at slaughter, we subtract the difference between each. And the younger age strategy had 27 days earlier, with better improvements in the average daily gain and feed efficiency, as well as the ham adiposity with lower production cost. So anticipation of the slaughter weight, slaughter age at 27 days earlier, with better improvement in average daily gain and feed efficiency, ham adiposity with lower cost, I recommended the younger age rearing strategy. However, another message could be that pigs with greater slaughter weight class are associated with pigs that were, allowed to grow until they reach their full growth potential without restricting or limiting any dietary nutrient. However, you have to watch out for the weight of the ham as well as muscularity of the hams, which might not be a desirable trait for the dry-cured ham industry. While the older age strategy is inefficient. And yeah, we also observed that sex had effects as the barrows produce hams that are heavier with better marbling than the gilts, but these observed differences were of small magnitude. So this is basically the take-home message, and thank you for your attention. Feel free to ask questions.
Thank you, Isaac. And now I'm opening the floor to the audience if you have questions to him. Oh yeah, no questions because the presentation is very clear. But I had one thought in mind. Because your pigs are not the typical growing pigs that
No.
yeah, it's I forgot the name of the breed, but it's a specialized one that you
Yeah,
receive at around 100 kilos.
yes,
Just
they are called
yes, yeah.
heavy pigs.
Can you say it again? Heavy
Usually,
pigs.
yeah, usually for dry cured ham production, heavy
Yeah.
pigs are desired, and the word heavy is because these pigs slaughtered at a weight
Mm-hmm.
beyond the conventional. So conventional slaughter pigs are around 110 to 120 or 30 kilos maximum.
Mm-hmm.
But for this special product, because of the dry curing process, which requires a long time of aging, 24
Mm-hmm.
months, and the water loss and the protein breakdown, lipolysis and proteolysis, enzymatic activities associated with the aging process, they
Mm-hmm.
typically prefer to use pigs that are heavier in
Okay.
weight.
Okay. And so for this particular breed, do
Mhm.
you already know their nutrient requirements? Are this fixed? Are this well known?
Yes. These breeds were developed specifically for this kind of production.
Mm-hmm.
And so we are actually testing these breeds for this breeding company. It's a
Yeah.
partnership. It's a big project, and they developed the breed, and we had to test all the requirements, and we set up this experiment in this way. Actually, I'm the second generation. There was a first generation who focused on the feeding trials, and I'm the second, and now we have a third generation PhD student who is working on the data base with the data from the finished material, so the dry cured meat from all these three PhDs, so 9 years of work.
Yeah. Okay. Okay. I was just asking because I was uh interested to know if you're looking at muscle and fat dynamics here because you want a very specific combination of two in your ham.
Yes.
If you already know the nutrient requirements, how much energy, how much nitrogen, or maybe particular amino acids you can, then maybe it would be the next step to try and play with
Hmm.
the marbling, with the uh, yeah. Are those
Yeah.
intramuscular fat that I'm seeing, or is it just
Yes, it's intramuscular fat.
okay?
This is intramuscular fat and the ham
Mhm.
size and the fat covering depth. So, yes, you are right, actually, Jim, because, when you know the genes, so when you know the genetic of your pigs, you can actually harmonize the nutrient supply according to the genetic requirement of that pig. And
Mhm.
because in addition, also you have to consider the environmental impact of all this intervention. For example, a question came up that feeding pigs with such a high protein diet, what about the urea excretion and stuff like that? And but I responded, because if you achieve 27 days good result compared to the conventional, it means you are reducing the environmental impact by 27 days.
Mhm.
And like I told you, this is a second part of the project.
Mhm.
We are looking at how will this intervention impact the environment as well. But yes, these breeds have been carefully selected for intensive growth, intensive fat deposition, and also marbling intensity.
Mhm. Okay. And then, oh, so you talk a lot about ham, but do you also use the other parts of the pigs?
So the other parts of the pigs, yes, we measured, for example, the large, the forelimbs, the belly, and everything, the head. We measured everything and kept the data, but because the aim of this project was to kind of have a joint collaboration with the dry cured ham industry, the breeding company, and the research center, which is the university now, we focused on harvesting the left legs of the pigs for our experiment. Of course, the other hams were used and they were sold.
Okay.
Yeah, yeah, sure.
Okay. Okay.
And
Okay.
every other
I
part
thought.
as
Okay.
well.
Okay. So, because I was just worried that you were just using two parts of the pigs after growing them for 1.5 years, and then okay. Okay. Thanks.
Yeah,
Uh,
you're
I'm
welcome.
gonna I'm gonna open the floor to other people
All
now. I've
right.
talked so much.
Sure, it's okay.
I have a question.
Hi, Ostani.
Yeah, thank you for your presentation. It was very interesting. I was also wondering if in the project you plan to look at behaviors of the pigs regarding the different feeding strategies.
Wow, that's very nice. I'm happy that you asked. And actually, I worked with 5 master students on this part. So the behavior of the animals, we had to, for example, provide what's this word now? So the toys which they will play with. So we put some toys and some shrubs in, and there is one interesting pig, for example, that when a particular student comes, that pig comes to her directly, and because you can see aggressive behavior in some that are very heavy. You can see also withdrawal from the group among some certain pigs. And yeah, but these were not captured. But yes, we had measurements on some behaviors. And also, we measure what time, for example, all the pigs are most active. And during weighing, when we have to remove them from their pen one by one, how do they interact? But it wasn't reported here.
Nice, because I know from a previous study that feeding strategy with lower protein lead to more like tail biting. So I wonder if it's something you could also observe. Yeah.
Yeah, thank you very much for for this question, because one of the authors of the paper is Paulo Carner, who developed this pig genotype for this breeding company. And yeah, we work together as well. They're selected for so many factors genetically, which includes tail biting effect and the effect of boa tent. So we actually did not have incidents of tail biting in our pigs, but we had a lot of problems with lameness, for instance. And because the pigs are too heavy, so they cannot, their body cannot carry their weight, some of the, especially in the greater weight class, and to load them to the truck was a problem, for instance. And we cannot allow the use of electric teasers, for instance. So it's a bit challenging, and we have to wait for the peak hours, otherwise we have to slaughter it there. So yeah, I really wished we observed this, but in this is an experimental. But like where I work now, we have a lot of issues of tail biting, but this is because this is a farming setting, and you can see tail biting incidences that are already healed, but in the inside you will have a lot of effects like the bone ossification, the how do you call it? So you can see along the spinal cord of the pigs, the cerebral bone is kind of perforated, and you can also see a lot of pores in different parts of the carcass. So for example, you open this ham in this part, you can see pores there, and this is effect of tail biting because infection have already gone in and has spread throughout the body of the pigs, and you have to discard the carcass. So yes.
Very interesting, yeah. It sounds like a very complete project.
Yes, actually, luckily it was. I wanted to show those kind of pictures, but it's a bit disgusting to see the parts and stuff. Maybe in the next presentation we can have a look at those industry-based aspects.
Thank you.
You're welcome. Maybe I can try to show some. Okay, it's different. Since we have some seconds, maybe I can quickly show you one. Okay. And maybe I can zoom this picture. Can you see it? So related to your question earlier.
No, we don't see the photo.
No.
Ah, you don't see it. Okay.
The slides.
Okay, just a second. I have to stop sharing and share again. Okay, share window. So for example, you can see this, and I actually also investigated the microbiome of the dry-cured ham itself, but since it's not part of the study, I didn't project it. But typically, because when you take the green hams to the ham factory, this part is usually covered with rice flour, and the product can go through the aging. And because already there is an intrinsic microbiota on the ham, they are actually, let me say, facilitating the rate of deterioration of the ham throughout the aging process. And when this goes to the market, you can find a lot of carcinogenic predisposing microbiota on the ham, for instance. And one of the findings we made was related to these pathogenic bacteria that are associated to the surface of the ham. Of course, some might grow as depending on hygiene during the aging, but with tail biting effects, there are so many aftermaths. So you can see a pig who had experienced tail biting during the rearing phase, and then at slaughter, the tail biting was healed, but after evisceration, you can now see more consequences of that.
Okay, thank you for sharing this picture. It's very interesting to see. Yeah.
Yeah, you're welcome.
Thank you. I don't know if there are any other questions.
Here are classical ones as well. And you know the tail is somewhere around this part.
Okay.
Yeah.
Okay, I think that's it. We're not getting any more questions. Yeah, so with that, thank you, Isaac. Again,
Thank
this
you,
webinar
too.
would be available in the PIGWEB YouTube channel. And yeah, thank you. Good luck on your next steps. I think you just finished your PhD recently, and I hope your career goes off to a very nice start.
Thank you so much. And thank you all for attending and the questions and suggestions. Yeah.
Yeah. Bye.
you.
Thanks.